So let's look at the indefinite integral, the antiderivative of quantity 2z minus 1/2 squared dz. So we do have a power rule, but this is a function inside here. Right? This is a function, 2z minus 1 over z. And so I need to expand this out. Again, I can't use the power rule because the power rule says very clearly that if I have the same variable in which I got the differential, so it's got to be the same variable raised to the r power, then I can use the power rule. But looking here, I've got a z, right? That's my differential. The differential is with respect to z here, and this is not the same, right? This is a function in terms of z. It is not z all by itself. So I cannot use the power rule. Now again, I have to go back to algebra. So this is equal to the indefinite integral of 2z minus 1 over z times 2z minus 1 over z dz, which is equal to, what is this, 4z squared. Right, I'm going to have a negative 2z here, another negative 2z there, so that it'll be a minus 4 over z, and then plus 1 over z squared. Or if you will, just get our, so we can see all our powers, 4z squared minus 4z to the minus 1 plus z to the minus 2 dz. So power rule says, okay, this is equal to 4z cubed, and then that cubed has to come down and divide out. Minus, oh, this is a negative 1, right? Notice what would happen if I just blindly did the power rule. I would say, oh, this is minus 4z to the 0 divided by 0. So that right off the bat tells me, ooh, I did something wrong. That's not what that is. I can't be dividing by 0. But I remember that, oh, if I have got a negative 1, that's 1 over u du, or 1 over z dz. Its antiderivative is ln. So this should be minus 4 natural log of the absolute value of z. And now I can do power rule here. So let's be minus z to the minus 1, and then all plus a constant. So that's our answer there. So how do we use this in terms of the definite integral, right? We've got the fundamental theorem of calculus. Well, if I want to say the integral from negative 1 to 1 e to the x dx, well, I know that its antiderivative is itself. Right? That's what Rule 7 says. The antiderivative e to the u is e to the u, plus a constant, if you will. So this is equal to, by the fundamental theorem of calculus, e to the x evaluated between negative 1 and 1. Notice I don't have to put the constant here. I could choose any constant. Fundamental theorem of calculus says any antiderivative will work, and so I make my life easy. I just choose my constant to be 0. And this ends up just being e to the 1 minus e to the minus 1, which more naturally would be e minus 1 over e. And that's what that definite integral is equal to. Let's say I want to know the integral between 2 and 5 of x minus 1 over x with respect to x. Again, don't trick yourself into thinking there's some quotient rule, that this is just the integral of the top divided by the integral of the bottom. Remember how what's the right word? How just kind of messy the quotient rule is for derivatives. Well, we don't have any expectation that there would be an easy quotient rule for antiderivatives. In fact, there is no such rule. But a little bit of algebra says this is the integral from 2 to 5 of 1 minus 1 over x. And now I can take the antiderivative of this because I've got a constant here and I've got 1 over x. I know its antiderivative, and so this is equal to x minus the natural log of x, all evaluated between 2 and 5, which is equal to 5 minus the natural log of 5 minus the entire quantity, 2 minus the natural log of 2. So I've got 5 minus 2, that's equal to 3. And then I'm going to have negative 5 natural log plus ln of 2. So I could write it as this, plus natural log of 2 over 5. So that would be, that could be our answer. So in the next video, we'll do some exercises in which we use the antiderivative or the indefinite integral to find a position function given velocity.